Hello everybody, my name is Dylan. Welcome to another Educational Bytes implementation short. Today we will be finishing up our linked list activities with some more linked list functions. So let's go ahead and jump right into the prompt analysis. So we have a search function that we need to implement called linked list search that takes a number, traverses through the linked list, and returns true if the number exists and false otherwise. Okay, so already we can see that we have this true-false return type, meaning we're going to be returning a Boolean. So we can check that off the list. And now we have some sample output. So we're going to actually have to modify the main to make sure that we get the expected output here. But that's simple enough. It's just some cout stuff there. And so what we want to do here is we want to go ahead and take a look at our option 1 in our starter code. And we want to go ahead and fill in our return type. We know we want a Boolean here. Now, what parameters will we need to make sure that we have all the necessary data to complete this function? Well, we know that we're given a number to traverse the list with, and we know we need to traverse the list. So we'll definitely need at least some search data and a node pointer, right? We'll need the node pointer that refers to the head of the linked list. So let's go ahead and get that in there. Awesome. And now we're going to just go ahead and execute the same sort of traversal we did in the last few linked list functions in the previous video. So first we'll create this temp variable to track the linked list traversal so we can avoid traversing with the head itself. And then we can just go ahead and actually traverse the list with that same while loop structure where we are checking if we have reached a null pointer. And then, so the operation that we want to do here is we just want to check if some sort of data exists, so we can just use a nice little simple if statement to achieve this end, right? So we'll say, okay, how do we access the data in a current node? We use the arrow operator on that node. So if pcur data is equal to the search data, then we can just return true right away. No need to go ahead and traverse through the rest of the list because we've already found our search data. And then this is kind of the bulk of the code, but we also need to make sure that we're advancing our pointer. So let's go ahead and do that. Advance pointer. Right? So this way that we're going to be repeatedly looking at a new node for each iteration of the while loop, and we won't just iterate over the same one forever. And then if we get to this point, that means that we've went all the way through the linked list and none of the search data matches. So we've went all the way to a null pointer, so we can just return false if the control reaches this point in the program, right? So that's all there is to this one, guys. We're just searching the linked list, we're using some data, and we're doing this kind of natural traversal that we're getting a little bit used to, and our operation is just a simple if statement which returns a Boolean. Nice. So let's go ahead and test this one out. So go ahead and run the solution code. So let's see, let's make a long list. Let's do 3, 6, 9, 3, 4, 6, 10, 25, 7. Okay, that's long, right? So then let's go ahead and search for a value. So it says your choice is 1. Oh, by the way, guys, there was a problem in the starter code if you're doing this as a lab activity and not as just an educationally enriching video. In the starter code, the main did not have, where is it? This should have a space here. Yeah, I'm executing a different solution, so that's why it didn't reflect that way in the output here. But let's go ahead and search for 25. As you can see, the number you entered exists in the list. So we have implemented this function properly, and now we just need to make sure we create the correct output statement. So there's a bunch of ways you can do this, but the way I like to do it is we just go ahead and so we see that if it does exist, you still have the number you entered as this constant string is going to be here, so I just print that out before we make our decision. So we'll just go ahead like this. Also, it doesn't hurt to go ahead and comment up our code and break it up a little bit so it's more legible. So we're going to read in our search data here. And then over here, we are going to display our output using the search function that we just wrote. And so we're just going to say, okay, well, we know that we have this constant x. So if the number you entered, and we just have to decide whether or not it exists or does not exist. So we can just use a simple if else. And since we know our function returns a boolean, we can just use it inline in the condition, right? So in this if statement here, oops, that is not pretty. And unfortunately, my auto format's been weird lately with these switch statements, so I'll just manually fix that. Since we know that this is going to return true or false, the if statement will be able to decide what to do with the function called directly inside of the conditional expression here. Awesome. Don't know what this is all about. We can just ignore that for now. So yeah, so we have that, and so this is going to output everything we need, and then we just need to end it with the rest of the constant string, which says in this list, right? So if it does exist, it'll say exists, and if it does not exist, it'll say does not exist, and then we just have to terminate it with this, and then that'll give us the output that you see down here. Awesome. Okay, let's move right on to step number 2. So for step 2, we want to write a function that sums all of the numbers in a linked list. So pretty straightforward. We just say, okay, this is the sum, and we just have to go ahead and calculate that with this function. So we can go ahead and get rid of our to-do here. We've already finished this function. Nice job, everybody. So yeah, let's go ahead to this one. And so we're getting a sum of all numbers, and we know that our linked list contains only integers. So it's going to return an integer sum of those numbers. And then as far as parameters go, we can think about, okay, so what do we need to actually get this done? Well, we could always create the integer value that we're going to return from within the function and then just return it there, so we don't need any sort of parameter there. But we do need to traverse the linked list, so whenever we're doing that in this fashion, we're going to need a pointer to the head of the list. So same kind of routine as last time. We're going to get this temp pointer to go ahead and traverse through the list. But then the difference is, we're going to have to initialize this sum. And here, so you can just declare it, but then you run the risk of having a garbage value be returned if the sum never gets incremented. Or I'm sorry, you have to initialize it regardless, because even if the sum does get incremented, you're going to have some garbage value stored there. So we initialize the sum to 0. Again, this is kind of assuming that there's positive integers. I guess I suppose it would also work with a combination of negative and positive integers. It would just be like a deceptive sum. But anyways, continuing on with that, so we've initialized our sum to 0. We've initialized this temp pointer to traverse through the list, and now we just want to traverse through the list. And you guys may have been kind of getting used to the structure by now. When we traverse the list, we just go ahead and check if the current pointer is equal to the null pointer, and if not, we go ahead and do some more operations, and then we go ahead and advance the pointer. So in this case, our operation is just incrementing the sum. So for each node in the linked list, we just want to go ahead and add that node's data to our sum. So we can just use this plus equals operator, pretty simple there. We're just saying, hey, whatever the sum's value is, go ahead and add the current node's data to that sum. And then, as usual with this linked list traversal, we want to go ahead and advance our pointer here. So that actually takes care of the function. We just need to return our sum at the end. So yeah, it's kind of weird at first to think about it, but drawing pictures of this stuff, again, like I said in the last activity, will be really, really invaluable in understanding how linked structures work in general. So now we've gotten this taken care of, we just need to take care of our output statement. I guess I can get rid of that to do later so it's not to waste your guys' time. And if we go to our poorly formatted switch statement, I don't know why my auto formatter makes these on the same line. Oh, also guys, you might run into an error where it says jump to case or something like that. So sometimes C++ switch statements are weird, so you'll need to like include an explicit block. Here, I'll show you what it looks like. You'll want something like this, and then I'll just paste the output that we're looking for in this all in one go, one fell swoop. Okay. So to avoid this error that you may or may not be getting, you just want to include an explicit block for each case. Just a little fun fact, I guess. The reason that this error kind of appears is because data that you initialize in one case is visible within the scope of the other cases if there's no explicit blocking like this. But its value can't be accessed. So it causes all sorts of weird problems, and I guess the compiler just won't allow you to mess around with that. So yeah, and then very simple, guys. All we're doing here is we're just saying, okay, well, our output says that the sum of all numbers on this list is colon space and then our value. So we can just go ahead and have a print statement that does that, and then go ahead and redirect our the return value of our get sum of all numbers function into that print statement, and then just finish with a new line. So if we test that one out, we can do something easy where we can verify the sum. So if we just do 1, 2, 3, 4, 5, and then we go ahead and display the sum, you can see that the sum of all numbers on this list is in fact 15, and we know that 1 plus 2 plus 3 plus 4 plus 5 is obviously 15. Okay guys, so that actually takes care of it. I know I went a little bit quicker this time, but I was hoping that we were kind of getting the hang of linked lists. But yeah, leave any reactions down in the comments. But yeah, I'll see you in the next video.